probing. It's been around for many, many years. In-cycle measurement, spindle-mounted probes, the likes of which are supplied by Schreiner and many others, are used to quantify the performance of the manufacturing process. These are typically used to assist with setting up a component. And we're generally using can cycles on machine tools to measure things like bores, slots, square edges, flat faces, to confirm a component is accurately set up on a component. At the same time, those same probing cycles can be used to measure the quality and dimensional accuracy of components throughout the manufacturing process. So we can confirm, has a hole been drilled to a specific size? If not, take steps to fix the problem. But as part shape complexity becomes more organic, these can cycles on CNC machine tools, they kind of run out of steam. They don't provide the level of capability to allow you to measure those 3D shapes. And so with that in mind, there is a real place for dedicated metrology software products. And obviously that's what we're here to talk about today. So historically, the Autodesk solution for in-cycle measurement for both part setup and quality confirmation would be using these two products. So PowerMill for the CNC manufacturing, the CNC machining, and PowerInspect for metrology. PowerInspect being a specialist 3D measurement surface that can be used to measure components with spindle-mounted probes, so on-machine verification, or indeed using coordinate measuring machines or laser scanners and so on. And so traditionally, the Autodesk solution would consist of two products. That's two learning curves, two licenses, two individual NC programs that need to be managed, exported, and saved onto the CNC machine tool. But it's kind of twice the processing, twice the effort. So there's a real challenge there, and our existing customers have provided feedback that they wanted that challenge to go away. And so I'm very pleased to announce that with the release of PowerMill 2019, specifically the 2019.1 release, we've now included surface inspection probing within the PowerMill product itself. So let's talk about what that looks like and how it helps manufacturers. As I say, within PowerMill, we've now got probing, allowing you to define the actual probe tool itself. So in this case, you can see a stylus being defined using parameters. Alternatively, if we wanted to, we could preload the outline that defines the probe body, so a Schreiner or OMP400 and so on. Once the probe has been defined within the PowerMill product, we can then go on to start generating the probing program itself. And this is done in a number of ways. Either we can click discrete points on the model that we want to measure, which is what you're going to see on screen in a moment. So you can see here, this short video shows that we've identified that we want to measure specific points, and then we literally just double click points on the model where we would like to measure the part. Nice and simple, nice and easy. Now alternatively, if we want to do some more complex probing, we can define wireframe geometry. So you could sketch wireframe onto the model that you want to probe. You can extract wireframe from the underlying surfaces as well. Either way, you end up with a piece of wireframe geometry that defines where you want to measure the part. And we can see that taking place here. So in this case, we've sketched geometry on the model. That generates wireframe. That wireframe can then be edited. And you can see that in this case, we're redistributing points on the geometry so that we've got 15 or 18 evenly spaced points on the curve where we would like to do some measurement. Now the magic here is, because the probing programs are within the subtractive manufacturing workflow, PowerMill, we're able to combine probing and milling in a single workflow, in a single NC program. And with a suitably configured post-processor file, we can output a single NC file that you can run on your CNC machine tool that will mill and then probe the component, all within one workflow. So there's some immediate benefits to be had there. Instead of learning two separate products, two licenses, two costs, your team is effectively using one piece of software. So straight away, there's a massive saving there in terms of your costs and your learning curve. So here we can see an example of an NC program that's been output from the PowerMill product that includes milling, and now you can see at the bottom of the screen the Schreiner cycles that are used to run the probing. So that's great. So we've got an NC program that's going to measure the part. We've export that NC program, put it on the machine tool, measure the component. The CNC machine tool will then generate a measurement file. That's the gold dust. That's where the information resides about the component that we fabricated. So obviously probing offers a number of huge benefits to manufacturers. It allows us to quantify and measure complex shapes. It's easy to measure a component if it's 2D. If it's a prismatic hole slot, that's easy to do. If you're trying to measure something that's complex, doubly curved, that's a whole lot more complex. And this kind of probing technology within the PowerMill product makes that so much simpler. Because we're able to integrate probing into the CNC machining process, that's a fantastic look for you, Mark. Thank you. Let's put a smile on the face. Because we're integrating probing into the CNC milling workflow, obviously there's some huge benefits to be had there. You've not got to manage the sort of combination of those two together. The CAM program is then responsible for driving the probing and milling process. So you've not got two people doing this, and the risk for human error is significantly reduced. And clearly we've got the ability within the PowerMill product to drive things like defining the tools, choosing a range of strategies, the tolerances that you want to use to measure the part, and so on. And as I've said a couple of times, the real magic here is that the NC program contains milling and probing cycles all in the same file. So it's an easier file for us to manage. But it doesn't end there. Once we've measured a component, that in itself is not good enough. We want to know how good is that part that we fabricated. Is it accurate? If not, where are the errors and what can we do to fix the problem? And so that's where I'm really pleased to reveal to you that PowerMill 2019.1, if you've got a subscription to that product, you've actually got the ability to upload your measurement results file, the file that's created by the CNC machine tool, and upload it to Autotest Drive. Now, Autodesk Drive is a cloud-based system, allowing us to store data on the cloud, allowing project stakeholders, my fellow engineers, my shift manager, my boss, my supplier, my customer even, to access this data using any device that's connected to the cloud at any time, anywhere in the world. Now, the traditional method of inspecting a component would involve creating a report, and that report would be a document that would be passed around via email, maybe even on a piece of paper. That's not as flexible as a cloud-based system that I can access these reports anytime, anywhere. So there's huge collaboration value to be had from reviewing the report in the cloud. And as we can see here, we've got a 3D view of the component that we've just measured. We've got a series of confetti markers positioned on the component. The colour of those markers gives me a clear idea of whether the part is good or bad. Green is good, red is bad, obviously. But I can dive deeper into the individual points to learn what are the errors. Is it a thou, 2 thou, 5, whatever the measurement is, I can quickly determine what those problems are. And because I can collaborate with my team members, I can make instant decisions about what to do next. If all of these confetti dots are green, I need to do nothing other than carry on with the process. But if we've got some red confetti dots, instead of me waiting to go and speak to my quality control engineer and find out what should I do next, a quick message to my QA guy, have a look at this shared view on the Autodesk Drive, let's decide what we need to do to fix this problem, make this part, finish making this part and getting it right. So there's clear value to be had there by having this collaborative team effort to review and make informed decisions about what to do with the part. So the benefits of this cloud reporting are that you don't require CAM software, or you don't need to be a programmer to interrogate those inspection results. You don't even need to have a license of Autodesk software. So I could share a link to that report with every one of you in the audience now, and on your smartphone you could have a look at that report without any financial commitment to Autodesk. These reports are very, very quick to create. You can see they're dynamic. It allows me to zoom in, spin the graphics around and interrogate where the problems are and collaborate with my team and make those decisions quickly. And crucially, I can view this information on any device, an Android device, an Apple phone, whatever it is, desktop. I can access all of this data quickly and easily through the cloud. But we appreciate that some manufacturers, for some reason, don't have access to the cloud, or they choose not to access the cloud. We understand that. And for those individuals, we still offer a desktop solution. And in this case, it's through our PowerInspect product. So you can see exactly the same measurement data is being displayed within a desktop environment, still offering me the ability to spin the model around, zoom in, interrogate the model and make decisions. PowerInspect also offers a deeper level of capabilities. So if I want to calculate best fits or delta transformations or do more complex analysis of the results that we've generated, PowerInspect is the solution for me. It gives me that greater range of capabilities, both on desktop and obviously we've talked about the cloud-based reporting previously. So that's what I have to say today. You can see that probing does offer huge benefits to manufacturers. It allows them to help set up their components in the early stages of manufacturing process, confirm that parts are positioned correctly. It also ensures that we can validate the quality of components during and after the manufacturing process. And so I'd invite you, if you want to learn more about this particular technology within the Autodesk product suite, visit PowerMill.com.